Okay, so go back to chapter 7. Remember, you had the population, you had the sample, and you had the proportion when it was given to you as a percentage. So now here, again, we're looking at a proportion. So estimating an interval, so another confidence interval, but this time with a proportion. So we're dealing with decimals. Proportions, we will use the Z chart. So I know it's confusing, Z or T, Z or T. We're going to make a chart in a second here, but proportions are Z, okay? Remember the standard deviation formula for p hat, okay, square root of PQ over N. Okay, and the confidence interval at the confidence level is going to be p hat plus or minus Z times the standard deviation of p hat. Okay, and then the value of Z is found from the Z chart for the confidence level. You guys still have your Z charts? That's okay. And we're frozen. Okay, so let's do an example with this. So let's say 44% of a sample of 1,000 people say religion is important to them. Okay, so let's find the confidence interval. And what are we going to do? I think we're going to do a 99% confidence level for this. Okay, that wasn't put it in here. So let's do a 99% confidence interval. Okay, so first thing, remember to verify that our assumptions are satisfied. Remember with a proportion, it is NP and NQ are greater than 5. All right, so let's find our P and our Q. So if 44% of people say religion is important to them, our P is going to be 0.44, which means our Q is going to be 1 minus 0.44, which is going to be 0.56. So 1,000 times 0.44 should be greater than 5. It is, and 1,000 times 0.56 is also greater than 5. So our assumptions are satisfied. All right, step 2, we are going to go to the Z table to find the value T that corresponds to the desired confidence level. So if you don't have the Z table, you can also, remember, go back to the beginning of chapter 8 with our little chart and our standard confidence levels here. Okay, so confidence level for 99%, Z value 2.575. Okay, so you should be able to do most of them with these confidence levels. There might be a couple problems on your homework that have some odd confidence levels, but as far as your test, you're going to see these ones. All right, so we had that as 2.575. So the margin of error formula is going to be Z times the standard deviation of the proportion. Okay, so we need to find the standard deviation of the proportion using this formula here. So the standard deviation of my proportion is going to be given to me using the square root of P times Q, so 0.44 times 0.56 over sample size, 1,000. So let's go ahead and find that. So square root, then parentheses, 0.44 times 0.56, so that's my numerator in parentheses, then divided by 1,000, and then I'm going to close out the square root. I put 100, thank you. I got to redo it. 0.44 times 0.56 divided by 1,000. All right, 0.0157. Did you guys get that for the standard deviation? Everybody? All right, good. 0.0157. We'll do 4 decimal places. All right, so Z times this value is going to be 2.575. times 0.0157. So there you're going to get 0.0404. Okay, so that is my margin of error. So using the value of the calculated margin of error, find, and that shouldn't be an X bar, that should be a P hat. You can change that there. P hat plus or minus E, which is 0.44 plus or minus our E, 0.0404. So 0.44 minus, we get 0.3996, and then plus, we get 0.4804. So our confidence interval, 0.3996, 0.4804. All right, and round however it's asked. So what am I actually doing here? Go back to the context of the problem. 44% of people in a sample of 1,000 said religion was important to them. So here, what you just did is you said, I am confident, because you use a confidence level. How confident are you? I'm 99% confident. I am 99% confident that the true population proportion, it's a little wordy, of people that say religion is important to them is between 30, we can round this to 40%, is between, so these numbers are percentages, 40% and 48%, based on this sample. So finally, so long sentence, but you got to cover all your bases here. Okay, know that you're basing it off of a sample, and it is the true population proportion based on that sample and how confident you are. So I am 99% confident that the true population proportion of people that say religion is important to them is between 40 and 48% based on this sample. That's what we're actually doing here. And there is no calculator button, so no Z interval, P interval, there's no P hat interval for this calculation. So this one is the one that you do have to do by hand here. Formulas are given to you. You just have to be able to execute it. All right, so let's talk about example 7. All right, so according to a 2014 Gallup poll, we have 1,450, so 1,450. Notice the samples in this section are a lot bigger than the ones we've dealt with before. So usually with the proportions, your samples are a lot bigger. 21% of young adults said that college loans and expenses were a top financial concern. Construct a 97% confidence interval for the proportion of all young adults who report that college loans expenses are the top financial concern. So you're going to go based off of this sample. You want to find a 97%. I'm 97% confident that this interval of people are saying this, that college expenses are a top financial concern. I imagine that in 2020, that number is probably a lot higher. Okay, but this is a little bit old. I might need to update that for next semester and make it a little bit more recent data. All right, so our sample size, 1,450. P hat, that's our percent, so that is 21, so 0.21, which means our Q hat is 1 minus 0.21, which is 0.79. the standard deviation of p hat is going to be the square root of p hat, so 0.21, times q hat, 0.79, over our sample size, 1450. So let's go ahead and get that number. So square root, parentheses, 0.21 times 0.79, close parentheses, divided by 1,450, close, 0.0107. Okay, always double check that, so maybe run it through twice, just to make sure. I don't want you guys to do the whole problem right and get it wrong because you did something like put 145 instead of 1450. All right, what's the z-value for 97%? Look that up in page 2 of your packet. Good, yeah, 2.17. Good. All right, so then the margin of error is going to be z times the standard deviation of p hat. So 2.17 times 0.0107. 2.17 times 0.0107. We're getting 0.0232. So then the confidence interval is going to be p hat plus or minus the 0.0232. So p hat plus or minus RE. So our p hat is 0.21. So 0.21 plus, actually let's do minus first, minus 0.0232. It should be a 2 there. I'll fix that. And then 0.21 plus 0.0232. So there you are getting 0.1868, 0.2332. Okay, so what does that mean? I am 97% confident that the true population proportion of young adults who say that college loans or expenses are a top financial concern is between 19 and 23%, or 18.68 and 23.32% based on this sample. Any questions? Good. All right, moving on. We're going to go backwards here. So now this is going to ask you, how big of a sample should I have to make sure that I have an accurate confidence level? Okay, so that my data is accurate. So how big does my sample need to be? So for P, so this is for proportions. So we did this in 8.2 for populations. We did not do this in 8.3 for samples because we already have, it wouldn't make sense because we're already given a sample size, right? So here, now for proportions, we can do this. So here's our formula. The sample size would be given by z squared times p hat q hat over the margin of error squared. Now, sometimes p hat and q hat are not going to be given. In that case, you're just going to use 0.5 for both. Okay, so 50%, 50%. So let's look at an example. So what is the sample size needed if I have a margin of error, I want to be within 0.03, so 3% margin of error. What is my sample size that I need? With my p hat being 0.32 and a 99% confidence level. Okay, so my p hat is 0.32. My q hat is 1 minus 0.32, which is 0.68. My margin of error is given to me in the problem, 0.03. I have to find the z associated with 99%. In our chart, 2.575. Okay, now remember, if you guys don't have the chart to find the z level, I just want to go over that real quick. For 99%, you would do 1 minus 0.99. Now that is one side of the tail. So on the curve, it would be two sides of the tail. So divided by 2. And then you would go inverse norm. So second distribution, inverse norm, 0.005, 0, and 1. And then that would give you the value. And they're positive and negative because it's both sides of the tail. Okay. And if you forget going over that, then you want to go back to 8.1 because we did a bunch of examples going over that, how to find those values. But then also you have your chart. Okay, so we have everything we need. We just need to plug this into the formula. So the formula is going to be n is going to be z squared. So 2.575 squared times p, so 0.32, q, 0.68, and then over the margin of error squared, 0.03 squared. So that's just really working in your calculator. What is 0.03 squared? So I have that. So that is 0.0009. Okay. All right, so 2.575 squared times 0.32 times 0.68. So I'm going to do the top line, and then I'm going to divide it by, and then I'm just going to put in here parentheses, 0.03 squared, close parentheses. Just so it knows that the squared you got to do first before you divide. So there I'm getting 1603.14. Where do we round when we're doing the sample size problems? Do you guys remember that from 8.1? We're always going to round up. We need the sample size to be large enough. So if I round it down, I might be 0.13 off from my calculation. So I'm always going to round up. It's always better to have more in your sample than not enough. So 1604 is going to be our sample size here. I'm going to use my little curly equal signs because that means I rounded. 1604. So how much would the margin of error decrease if we increase the sample size to 2,000? This is just an example here. They use 2.58 instead of 2.575, so it might change slightly here. You're just reworking this algebraically. Okay, so if I reworked it algebraically, what happens here is I change the sample size to 2,000. Then I would multiply both sides by e squared. That would cancel out the e here. Then I would divide by 2,000. That's why you're seeing this divided by 2,000 here. And then that gives me e squared equals all of this divided by 2,000. So then to get rid of the squared, I do the square root. Okay, so if you're trying to find the margin of error decrease, that formula is going to be z squared times p hat times q hat over n, and then that whole thing in the square root. So just the same formula, just reworked to find the margin of error. So if I work out that problem, I'm going to get 0.0269. So the margin of error decreases slightly by having a larger sample size. So the larger the sample size, the smaller your margin of error, the better everything is. Okay, less error means you can be more confident in your results. So before we go on, I just want to go over when to use T, when to use Z. Okay. All right, so we are going to use Z when you have a known standard deviation. So the sigma is known, which is the population. So it'll say the population standard deviation. Okay, when it is normally distributed, Okay, and then also when we are dealing with a proportion. Okay, so the problem is given to you as a percent. Okay, so in a proportion, they're just going to give you the P or the percent, and they're not going to give you a sample size. Or sorry, they are going to give you a sample size. They're not going to give you a standard deviation. So, but because it's a proportion, we use Z. Now, if they do not give you a population standard deviation, that is when you use T. So that is when this is unknown, okay, but S is known, which is your sample standard deviation. And then this needs to also be normally distributed. All right, so that is the little chart here for Z or T. When you were doing the problems in your Chapter 8 homework and your quiz, you want to ask yourself that first. So we can pick up with the classwork in our next class, and that is the first question we are going to ask ourselves.